you got?
That's second anyway.
Suck it in there. They don't? Sure. All right. So many of the questions on the quiz, the online quiz, asked about bacterium in a colony. You start with one, they double every so many minutes. How many is left after a particular period of time? So let's say start with one, and let's say they double every how long? Every minute?
Oh my gosh.
Pretty fast growing. Fast growing.
Like 20 minutes.
Every 10 minutes.
Just 10.
That's like 30 minutes.
So double
Yeah.
every. We'll go 20 minutes just to make things work out well. And then obviously we can ask how many are left after 40 hours. Okay. Now, in looking at this question, you may say, okay, well, let's do doubles every 20 minutes. It started with one. How many is left after 40 hours? Well, you know, there's a couple of things you can do here, and the quiz looked for the easy way of expressing the answer. It didn't want you to actually go through and count the actual number. It just wanted you to give an expression that tells you how many there are after 40 hours. Well, so the first thing you do is you identify they double every 20 minutes. Okay, well, all right, so every 20 minutes there's twice as many as there were before. Okay, so 20 minutes. All right. Now, we're working with hours, right? We're wanting to know how many are left after a certain number of hours. Okay, so we have 40 hours. And how many 20-minute blocks are there in 40 hours? Okay. Maybe
It's 800, isn't it?
3 times 40. 16 blocks of doubling. Okay. So 120 times in those 40 hours, we are going to double the number of bacteria we have. Okay? Well, if we started with one, and they double every 20 minutes, they double 120 times. And so what we get is that there are 2 to the 120 bacteria left after our 40 hours. Okay? And working with these problems, what you need to do is you need to look and say, how long does it take for these things to double? Okay? In this case, 20 minutes. How much time am I actually looking at in terms of, in relation to the amount of time it takes to double? Here, 40 hours. I need to take my 20 minutes and I need to figure out how many 20-minute blocks are there in that 40-hour time period. Once I have that, then it's just a matter of setting up the exponential notation like we have here. And we're done.
Alright.
Logan, do you have a question on this? Or?
Yeah.
Okay, go ahead.
Okay, the 3, did you get it because it's 20 minutes and it's 3 to 60 minutes?
Right, there are, in 1 hour, there are 3 20-minute blocks.
Okay, and then why did you do the 1 times 2?
That's how many we started with. We started with 1,
Okay,
and then it doubled every hour. So we started with the initial amount times the...
So if it did triple, you put a 3 there.
No, the 3 would be here.
Yeah, that's what I'm saying.
The triple, yeah. Go ahead. All right, other question? If we started with 15 instead of 1, how would that change?
Be 30. No, you put the 15 where the 1 is.
I put the 15 here. And then everything else is the same. Okay. Nicole, did you want to ask about the one on the quiz?
I just like, do you know the answers for it?
So which one's the one on, the one that I posted or the online quizzes?
No, the one that you posted.
Do I know the answers? I know most of the answers.
What were the answers to?
You asked me a part, I'll tell you what the answers are.
Well, I didn't do A, so I didn't know what that was.
Okay, so which part do you want?
And then it was like, what, how many, or it was like, basically getting to 4,628.
Okay, so we start with 1. Double every minute. And we want to know how many there are. We want to know how many or how long. So there are 4,628. Okay. So, simple question relating sort of a doubling type problem with a problem asking about how long it's going to take until there's a specific number of these bacteria there. So, how do you solve the problem? What do you do?
Equation 1 times 2 to the x.
Okay. 1 times 2. I don't use t when we're talking about times, just makes it a little easier. Okay. So this expression right here tells us how many there are left after t minutes, right? Okay. So then, what are we setting this equal to? Right. We're setting that equal to the 4,628, and now we're just trying to figure out what t value makes this true. How do we solve problems like this?
Logarithms?
Right. Whenever we have our variable up here in the exponent, the best tool we have to get that t out of the exponent is to use logarithms. And so we can just take a logarithm of both sides, and the logarithm we choose to use is whatever logarithm you want. You want to go log base 10, that's fine. So you take log base 10 of 2 to the t, and that's going to equal log base 10 of 4,628. Okay. And now, we just use our properties of logarithms to simplify this down. We move the t out in front. We have t times our log base 10 of 2 equals our log base 10 of 4,628. Okay. And now what do we do? Now we just divide by the log base 2 or log base 10 of 2, and we get our t log base 10 of 4,628. Log base 10 of 2. And that's it. That's the answer.
You don't have what solve it?
You don't have, that is solved.
I mean, like.
The right hand side's a number. I don't want you putting this as a decimal.
Okay.
That just leads to.
I thought it was a whole number.
No. That just leads to more issues that, of rounding and everything like that. And I don't want to.
Okay, that's what it is.
Okay. Alright.
You do the one afterwards.
The one after that?
Yeah, the one that takes the jar.
Okay.
Instead of a
So, same problem. It takes 1 hour to fill the jar. How long does it take until the jar is half full? Now, with most calculators, you try doing this, you get this 2 to the 60th you're having to evaluate, right? And that's a big number, and most calculators don't give you an exact value, they give you some scientific notation for it. But, hey, what's up? But, we can still answer this question. How long does it take for the jar to be half full? If after 60 minutes it's entirely full, how long does it take till it's half full?
That's true.
That's when it's so remember what's going on here. Remember what happens each minute. What happens each minute? You double, right? So if it's full,
Oh, so it's
it's
89 minutes.
that's 1 minute.
Oh,
It's
my
half
gosh.
full. So it's 59 minutes.
That's funny.
59 minutes for it to be half full.
So this would not show any work, just wrote 10 minutes.
There's not a whole lot of You don't, there's not a whole lot of work that you need to do in this particular instance. It's just,
Wait, hold on. So 1 minute makes it half full.
right, because we're doubling each time, right? If 1 full hour, it's full. 1 minute before that, there was half as many things, right? Because it doubles every minute. So you move back 1 time period, and you're half full. So that's what we're looking at next. Okay. All right, Ben, you have another question?
Yeah, on that first one, so they actually ask for time,
Right.
but the bacteria, you don't use the PERT.
No, you don't need to worry about that. What you're doing with that PERT is that's just a way of expressing an exponential growth problem. In this particular problem, we know that the easiest way to set this up is just to write it as 2 to the t, because it doubles every time period. So it's easier to just write it as 2 to the t. If you wanted to write that PE to the RT, you could do that, but you just kind of got to fiddle around with the 2 to the t to make it look like an E to the RT. This one's easier to work with instead of going that direction. Okay. All right. Other questions?
Which formula do you want? Remember that conversation
Which formula do I want?
for the,
You're talking about the exponential growth questions?
yes. So you remember the.
Right. I would prefer, whenever dealing with a question that says something is growing at a rate of some percent, in my opinion, and in the opinion of others that I've spoken with, since we're in a calculus class, we always want to use this formula for exponential growth. If we're talking about a problem that says, like, the population of town X is 100 people, it grows at a rate of 2.5%. What's the population after 10 years? This is the formula I want you to use to calculate that. Okay? The R in this case is that 0.025. P is our initial population. E is what it is, and then T is our measuring time. This is what I want to use for exponential growth, or any question that talks about something growing at a certain percentage a year. Okay? Unless I tell you otherwise, use this one. Okay? I know that the quiz sort of counted people wrong, depending upon which formula you use. There's this formula, and then there's also this formula. And depending upon which one of those you used, you may have gotten either a year ahead of what the computer said or a year behind what the computer said. I've emailed the publisher to ask about addressing that issue. I haven't heard back from them yet. But in terms of the way the questions are worded, I feel like this is a more appropriate formula. So I would say go with that. Okay. All right. That's easy. Any other questions? Cool.
Cosine is equal to 3/7 and negative pi to positive pi.
Okay. And then find the other ones?
Yeah. So
Okay.
there's 2 possible.
Is there 2 possible?
That was positive.
All right, let's take a look here. So the problem was cosine of x was equal to negative 3/7, positive 3/7. Really? Okay, that's fine. We'll deal with that. All right, and the question was so x between pi and 0. And our goal here was to figure out our goal was to figure out what the values of tangent and sine are. I swore when I put this up that there was a negative in front of the 3. It may not have come true. Let's put the negative in, and then this becomes a little less of a guessing game. Okay? All right, if this is a problem you're presented with and you're asked to find tangent of x and sine of x, how would you go about doing that? How could you find these other 2 values if all we know is the cosine value? Okay. Ultimately, what we're going to do is we're going to use our Pythagorean theorem, and in order to do that, we have to have a right triangle. So let's just draw a little triangle. Okay. In our picture here, you make x wherever you want it to be. You just have to there.